So welcome to the lecture on FPGA, Field Programmable Gate Arrays. The acronym is FPGA, and in most of the nowadays FPGAs are being used because the design can be done at a faster rate, and of course the cost is more. So unlike CPLDs where it consists of all the PALs, FPGAs consists of array of gates, that is gate array. So it doesn't consist of PAL, but it consists of gate arrays. So of course the function is same, but the architecture is different and technology is different. So an FPGA may be used in a design that need to be fabricated at a faster rate irrespective of its cost. And most of the designs and most of the projects in the fine layer would be based on FPGAs. So this is a typical FPGA architecture where the perimeter, of course the FPGA is an IC, it is also a single IC like CPLD, but the architecture is different. So FPGA is a single IC where you can realize a complex logic functions. The perimeter of FPGA consists of I/O cells, and the core of FPGA consists of logic blocks. The function of logic blocks is to realize a function, to realize the circuit functionality. And these lines are the interconnecting lines, or I can say interconnection resources. So this is a typical FPGA architecture, you have to remember this. So the architecture consists of logic blocks or configurable logic blocks. Configurable logic blocks, why we are saying configurable means according to the logic function you can connect or disconnect the internal connections of logic blocks. It is nothing but a programmability by using a fuses, as we have discussed in PAL and PLAs. And it consists of configurable I/O blocks, that means input-output blocks, programmable interconnections, so the connections are also programmable, so they are not fixed. It consists of a clock circuitry for each and every block. So whenever we are using clock, it is nothing but a sequential, and for synchronism purposes we use a clock. Additional logic resources such as arithmetic logic units, memory, decoders may be also be incorporated along with this FPGA to form overall system. So a system typically consists of an FPGA, additional circuits like memory, decoders, arithmetic logic units, and in some applications you also require digital signal processors. And the basic types of FPGAs are static RAM and antifuses type of FPGAs. So there are two types of FPGAs, static RAM FPGA and antifuse FPGA. So what is a configuration logic blocks and what does it contain? It contains a small RAM, it contains a logic function, logic circuit, and also flip-flops and the multiplexers. So flip-flop is used for synchronism purpose. Multiplexers are used to select one of the routing lines in the logic block, and it also consists of small RAM which is used to store the information. So this is a typical CLB circuit where it consists of actual logic blocks, and the outputs are selected by the multiplexers, and then they are given to the D-type flip-flops for the synchronism purposes, right? So once the function is evaluated, that is given to flip-flops based on the selection lines of the multiplexers, and this flip-flop will store the information and it will transfer the information to output based on the clock signal. So simple. First level logic blocks, second level multiplexers, and the third level is a flip-flops. And configurable I/O blocks basically used to bring the signals onto the chip and send them back again. It consists of I means input buffer, O means output buffer, and these are 3-state buffers. That means it has 3 states: logic 1, logic 0, and high impedance state. Already we know what is a 3-state buffer. And that also consists of a flip-flop where outputs can be stopped or synchronized with an external device that is connected to FPGA. So this is a typical configurable I/O block where it consists of flip-flop and some tri-state buffers, right? These are the 2 tri-state buffers, and these are the flip-flops, right, where the input and output data can be stored in these flip-flops. The programmable interconnect should be in such a way that it should transfer the information from one function block or one configuration logic block to any other configuration logic blocks. So of course there would be some long lines which can be used to connect critical CLBs, that is configuration logic blocks, and there would be some short lines which are used to connect individual CLBs which are very close to each other. So it is a direct concept, right? The CLBs which are far would be connected with long lines. They are categorized as long line interconnects, and the CLBs which are very closer to each other, they would be connected with a shorter interconnected lines, and these are programmable. That means you can remove the interconnection as well as place an interconnection based on the requirement. So the connections are not fixed, they are programmable. So in FPGA everything is programmable, starting from AND gate connections, OR gate connections, and the input connections, I/O connections, and the interconnect connections. So this is a typical interconnect switch matrix, how the interconnections would be there. Actually the interconnections would be in between the CLBs. This is one CLB and this is second. Of course, if you are considering 4 CLBs, this is how the interconnection switch matrix would be there. So there would be a matrix which closes, opens the corresponding row and the column of the interconnections. So this is how the data is transferred between CLBs. Data is processed by the CLB and the data is transferred through this interconnect switch matrix. And the examples of SRAM based FPGA families: Altera, Atmel, Lucent, and Xilinx. All these are companies. Just try to remember the different FPGAs which are developed by different companies. And finally, if you want to differentiate CPLD and FPGA, these are the differences. Architecture point of view, it is like PAL, right? It consists of PALs, but whereas it consists of array of gates. And the density means how many number of gates you can place in CPLD or FPGA. The density is low to medium. That means maximum is you can incorporate medium number of gates per unit area, and here medium to high. That means you can incorporate more number of gates per unit area so that you can realize more complex functions in less area. That is called the density. The speed is fast and predictable in case of CPLD, and FPGA is not fixed. It depends on the application, right? If you want to develop an FPGA for high speed application, you can. So it depends on the application. It is not neither slow or neither fast. It depends on the application. According to the application, you can tune the speed of FPGA. And interconnections are crossbar type of interconnections, and these are routing type of interconnections. And if you consider the power consumption, which is most one of the critical parameter nowadays, power consumption. So always for any IC, the power consumption should be less. So for CPLD, the power consumption is high, whereas FPGA, the power consumption is medium. Right? So these are the parameters on which we differentiate CPLD and FPGA. Architecture, density, means number of gates per unit area, speed, interconnect, type of interconnects that we use, and power consumption. So this is about the concepts of CPLD and FPGA. Thank you.